Welcome to the video for lesson 2, where we're going to be working with some theorems and also doing some numerical practice with these as well. So the first thing you might be asking yourself is, what the heck is a theorem? And that's okay, but in simple terms, a theorem is a rule, a principle, or statement that can be proved to be true. Now, theorems are used all the time to help work through mathematical proofs, and you guys have been exposed to these before. So first one that we can talk about is Pythagorean theorem. You use this theorem to help you find the third side of a right triangle, and without it, we would never be able to use this amazing equation of a squared plus b squared equals c squared. So you guys have been exposed to theorems before, but they were never really formally introduced, and in this unit we're going to start by learning about parallel line theorems. So the first theorem is alternate interior angle theorem. Now, on your note sheet, you're going to see that on the left, we have if, and then on the right side we have then. So how we read these is, if something on the left is true, then the next thing will happen. So that's usually how theorems are. It's if this, then that. So for the alternate interior angle theorem, and remember these are our z angles, it says two things. One, if two lines are parallel, then we know that alternate interior angles are going to be congruent. Now keep in mind, when you're using a theorem, it depends on the information that you have. We're saying if we can guarantee, if we are given that two lines are parallel, then we know that alternate interior angles are congruent. So, and this is a picture example here. It says if M is parallel to N, we can use our little parallel line notation there, then angle A is congruent to angle B. And we can say that because we knew we were given that M was parallel to N. The other piece says if alternate interior angles are congruent, then we know the two lines are parallel. So these theorems go back and forth. So you can see at this first one here, if we're given the parallel lines, then we can assume or conclude that the alternate interior angles are congruent. But also the second way, if we're given that the alternate interior angles are congruent, then we can conclude that the lines are parallel. So in this case, we have if we know, and this should say D and C. If angle D is congruent to angle C, then we know that M is parallel to N. All right, the next one that we are going to be working on or talking about is the alternate exterior angle theorem. Now, you guys know how to identify all of these angles from the previous lesson. However, these theorems are just telling you a little bit more information about the angles that you have. So, first thing says, if two lines are parallel, then we know the alternate exterior angles are congruent. So again, if we are given that P is parallel to Q, then we automatically know that angle A is congruent to angle B. Now, this theorem also goes the other way. If we're given that the alternate exterior angles are congruent, then we can assume that the two lines are parallel. So in this case, if we started with the fact that A was congruent to B, then we can make that conclusion that P is parallel to Q. Next one, we have corresponding angle theorem. Now, these are our F angles. And again, these theorems are very similar. So again, we're starting with one, if we're given that the two lines are parallel, then we know that corresponding angles are always congruent. And in this picture example, if we are given that P is parallel to Q, then using this theorem, we're allowed to use this theorem, and then we can say, hey, these corresponding angles are congruent to one another. Now, going backwards for this theorem, it says if corresponding angles are congruent, then we know the two lines are parallel. So if we are given, in our given info, that A is congruent to B, then we can assume or conclude that P is parallel to Q. So these theorems are all going back and forth, like they can go both ways. However, that's not always the case. There are only special theorems where you're able to use them in both directions. So don't ever assume that you can use a theorem both ways, but just know that for these you can. Next one, so all the angle theorems that we've talked about so far, alternate interior, exterior, and corresponding angles, if we know our lines are parallel, we know those angle pairs are congruent. This one, same side interior angles are a little bit different. Now these are our U angles. So you can see, like, you should literally get in the habit of highlighting these in your diagram. So when I say U angles, I literally mean this U shape here and this U shape here. So again, if two lines are parallel, then same side interior angles are supplementary. Now remember, supplementary means that we can add two angles and set them equal to 180. So again, if we're given that L is parallel to M, then we know that our same side interior angles, which are angles 4 and angle 6, we know that if we add them, we can set them equal to 180. Now this theorem also goes the other way. If we know that the same side interior angles are supplementary, then we know the two lines are parallel. So if we're given that angles 3 and 5 here add to 180, then we can assume or conclude that L is parallel to M. Now, we didn't really go over the highlighting for the other angle pairs. However, they're highlighted in your diagrams for you, and as you work through your test card, you guys are going to be highlighting them as well. All right, other properties that you're going to need and to use in practice are just always look for your vertical angles, and we can call these X angles, and we know that vertical angles are always congruent, and also always look for your straight lines, because we know that straight angles measure 180, so if we have a straight line in a complex diagram that's broken up into a bunch of pieces, we know we can use an equation, set it equal to 180 to help us build our story. All right, we're going to do some numerical practice problems, so you guys are going to follow along with these in your notes, and then you will practice some on your own. So our first step is to always identify the angle relationship that we're using or the property that we can use to help us solve the problem. So we're given all of this different info, and it wants us to find angles 1, 2, and 3. So I see that we're given this 114-degree angle here, and I'm also noticing that we have these arrows here. Now when your arrows are like in the middle, like they're not on the ends of your lines, this is a dead giveaway that we have our parallel lines. Okay, so first thing I see my lines intersecting here. I see vertical angles. So if I see this angle is 114, I know that this angle is also going to be 114 because they are vertical angles. Now, I'm given that my lines are parallel. So if I know my lines are parallel, I can look for alternate interior angles, alternate exterior angles, corresponding angles, and I know all three of those angle pairs are going to be congruent to one another. So highlighting is going to be your best friend when you're doing stuff in this unit. So I'm going to highlight the Z that I see. And when you highlight your Z, it's usually the corners are congruent to each other. So this angle would be congruent to this one. And then separately, we would have that this angle is congruent to this one. So using my Z angles or using my alternate interior angles, I can also conclude that this angle here is 114 degrees. And I should have used the other Z. I should have went this way. I'm going to clear it for a sec. So this is 114, and then the Z that we used, we're going to go this way. Because your Z's can go forwards or backwards, just so that we're consistent in using the inner corners of the Z that we create. So I know this is 114 degrees as well. So now I have angle 1, I have angle 2. And now for angle 3, I see vertical angles. So I know this is also going to be 114 degrees. All right, next one, find the value of X. So our first step, again, is to look to see, do we actually have parallel lines? Yes, we do. These arrows are telling us that our lines are parallel. And now we need to be able to identify the angle pair or the angle relationship that we're going to use. So here we're looking for our Z's, we're looking for our F's, and we're looking for the U shape. Now, it might take practice, but eventually you're going to be able to pretty much identify this stuff right away. But it might help to highlight to just see, like if you're like, okay, do I have a Z angle? It might help to actually highlight a Z or outline the Z with your finger to see if what you have is true. So let's just double check. So if I highlight my Z, the angles that I should have are the inner corners. I don't have that. This angle isn't in the inner corner of a Z, but I have nothing here. So Z angles or alternate interior angles will not help me here. Next thing I'm going to try the F's. So your F's, notice, they can be backwards, they can be upside down, and in this case we have a really weird looking F, but there it is nonetheless. And when you have your F's, you want to use, again, the inner corners. So I have corresponding angles here, and I also know that my lines are parallel. So I'm going to go back to my theorems. What theorem can I use here? I'm going to use the corresponding angle theorem, where it says if my two lines are parallel, corresponding angles are congruent. So I can go ahead, when two angles are congruent, all you got to do to make your equation is set them equal to each other. So 3x equals 5x minus 2, and then you would algebraically continue and solve for the value of x. All right, so that's it for lesson 2. Just make sure as you're working through your task card that you are highlighting. So the same way that you can use these pictures on the rightmost part of your note sheet to help you figure out how to highlight, and that will help you immensely as you're working through these things. So you guys are going to do the try it on your own problem so that you can get full credit for your video.